maybe 2 years. And I started off with design as my domain and slowly shifted to UI UX. And currently, I'm doing as a for a company. I'm a creative coordinator named JTech Mulan. It's a community, and prior to that, I've done 2 years of internships at different companies in the field name of UI UX. Okay, so yeah, this is a short intro about myself. So if everyone else in this room could, slowly introduce themselves, or get to know, we'll be having a very great time for the next 90 minutes or so. So what do you guys say? So I'd like to hear at least one or two people, unmute and speak, or even in chat, could ask me something, or just give a brief intro about yourself. It'll be great. Because this is a Monday, I mean, this is the Wednesday, right? Yeah, today is Wednesday, I believe. So Wednesday, a working day, and you people have all come here and, keeping aside everything. And, you have taken the first leap, to bring a major change in the way our Earth should be. And you are coming and you're being part of this hackathon. So, let's make utilize of, let's utilize this to the maximum extent. So let's start, going to this session. So do you guys know anything about this? Why is there such a session like prototyping with Figma, or what is the need for the prototyping session? So anyone, if you could chat or unmute. Okay. Okay. So I'll do one thing. Have no idea. So okay. Great. Arivaigan. So yeah. So Arivaigan, did I pronounce the name properly? Okay. So great. So yeah, so like we all are here to, on basis of the next 48, or no, not 48, like 60 hours approximately, you have to build a product. And why prototype with Figma, or what is the reason for placing Figma or prototyping as a sessions in the beginning of the hackathon? It is simple, and throughout the journeys we'll get to know most probably. So I like to convey that too. So before any product that we are pitching, or before any idea that comes into our mind, we always need some, user experience, user persona, etc. Like why we are building an idea. For example, that may be our one problem idea which we're gonna solve, or problem we're gonna solve, maybe only a problem statement for us, but not for the rest of the community, the rest of the people. So how do we analyze that, and how do we test these things, and what is the requirement prototype? So these all will be what we are going to cover for the next 90 minutes. And this 90 minutes, I like to divide them into three modules. And the first module will have a brief intro about the reason for the prototyping, or introduction, etc. And the next 30 minutes in the will be that session will be introducing you guys to the tool of Figma and its wide scope in the industry. And finally, and the third one session, we'll look into how prototyping and how easily we can create a prototype for our base ideas, like for the web mobile applications, and not just for this thing, for creating presentations, etc. and so on. So that is how we will be having a journey right now. So yes, are you guys ready to have this journey with me? Come on, in the chats. And yeah, okay, great, man. Okay, sure. So yes, so I think I will start sharing my screen. Okay. Okay. So I believe my screen is now visible, right? Is my screen visible?
Yes, yes.
Okay, great. So yes, prototyping with Figma is what we are gonna focus into today. So let's come into the question, like why? Figma, right? So initially I said why Figma. So Figma is a tool. If you like Google Figma, you will understand that Figma is just a tool that is gonna give you UI UX or that perspective. And what is UI UX? We'll come to that. But primarily we're gonna utilize Figma or exploit Figma for our use over here. You guys may have an idea, which you that is the reason you all are sitting over here. So how we can convey, and most of the time, sometimes we won't have the coding skills with us, or sometimes we may not have the basic the skills to present this to a pitch or in front of an investor or in front of a panel so that we can pitch our idea. So Figma may act as a tool so that you guys can pitch in your ideas without much hassle. Okay, so that is the reason we chose Figma. And Figma has been a great beginner friendly tool. So how to prototype is what we are going to look into, like how to design mobile screens and how to design web screens and how to do etc. So that will be what we'll be covering. Okay. Before that, before you prototype something, please jump back right into something. Most of the time, while we are doing panel discussions or all, people obviously ask us what is a use case scenario, what is this thing. So what is UX? Okay, I'm not going to give you theoretical background. Okay, so before we jump into that theoretical background, how much among this group is new to UI UX? Or well, let's put it this way. Okay, that framing is not okay. Like how many of you like are expert in UI UX over here? So we could get a brief idea into that so that eventually get an idea. So yes, so anyone could spam the chat. I know how to create screens in Figma. Okay, Meghna said that. Okay, fine. Yeah. So what we look into is called UI, and what we are gonna do is called user experience, like how or what is gonna be placed. So I like to show you guys some example, real life example. Okay. For that, I'm taking UX with ketchup as an example. Fine. UX with ketchup as an example for that. So what is UX with ketchup? So everyone over here must have used ketchup bottles, right? Yeah. Okay. So have you guys seen this ketchup bottle? Come on, just spam in the chats. Yes. Fine. Okay. Everyone has seen this ketchup bottle, and it looks pleasing. UI is good. It's pleasing, etc. So there are 2, 3 bottles of this thing, but we can categorize different models of bottle comes, designs come. We categorize them into 2 methods. One, the cap facing downwards. Okay. Next one is another bottle as such. Okay, on the left, what you can see is this bottle, which is, it's a most common. And how many of you have seen those bottles? The first one, and which is the most common bottles you see? The left one mostly. And all the left one, the most common ones you see on all the supermarkets, all the cafeterias, all the restaurants will be the most the ones in the left ones. Okay, so UI wise, both have different fan bases, and equally like look wise, it all into the perspective of an like people who sees these things. But what makes a difference is the user experience. I want to take you through the journey of let's assume a scenario where you have your samosas in your left hand, okay, in a plate. You're very hungry, you're in a hurry, you come back, the colleges are over, or you're in a lunch break, or you're in a break from office or something. You come over there, you have a samosa, and you want ketchup to be in there, and in the cafe or in the cafeteria, you see the left ketchup box. And obviously in ketchup box, in cafeterias and all, the ketchups will be obviously 50 percentage will be empty, so will be in the half of the ketchup, this thing, the quantity. So like the journey of putting the ketchup in that samosa is like a fight. It's a fight between our aim and our experience, plus our muscle memories. Okay, so you have to flip the bottle over, you have to give 2, 3 hits on the bottommost and wait for the ketchup to flow down and open the lid. And opening the some they will after opening only they'll flip it and hit. So that though the issue with that was you will hit and obviously it won't land in the place you want, it land everywhere else. So people with experience will close the lid. Then that is a very big hassle just to eat our favorite samosa or anything with noodles. Is this true? Do you guys feel so? Yes or no? Give me in the chat boxes. Hmm. Yeah. Okay. So this is a true journey that we face. But what about the ketchup in the right? So that ketchup, no matter what, it's resting is in the gravitational pull, right? That is where the opening lid is also existing. So in that such scenarios, the opening lid is placed by taking into the factor of human experience. So that no matter how much of a percentile of ketchup is left, you just need to open it and squeeze it. You'll automatically get the ketchup you desired. So this is how UX or user experience plays in the market and getting people attracted. So obviously, people with more of this thing, they will obviously go for the who have experienced the second bottle will obviously choose the second bottle whenever they are going, and that is how you make people's life much more easier. And this is one such example. And what it really means, right? What it really means. So whenever you're building a product or whenever you are designing an product, you always need to keep two things in mind. Obviously, the first thing is user, like the design wise, the concept, it should attract the eyes. So that is one thing. And the next thing is the user experience. Let's take into the example of Google Pay, Phone Pay. Obviously, you like Google Pay, right? Because of the user experience, very easy to do. So similarly, in real life also, there are many such examples. I want to show you this example of this lift over here. Okay. So what is the speciality of this? I say to Meghna right now. Okay, Meghna, give me a go to floor 21. So you will be in a hurry, like where am I going to press 21? It's like the user experience of this left case scenario is very hard to find, right? So this is where user experience plays in one case, and where user experience highly utilized. I want to show you another example. Have you ever seen this? So if anyone can comment on this. So chat be active. Like, have you seen this? What's the use case of this? Okay. So actually, this is nothing. This is actually parking malls. In the malls, parking the cars is very very hard to find, right? So like because you feel like there is a free parking, but you go inside and see, oh no, that was not a free parking. So this what it does is act as a sensor. So the cars, they see, okay, if the car is already the parking space is there, then it'll show green. If there is no parking space, it shows red. This is the best use case of using a scenario. And does this only belong to real life? It also starts to come into design also or into software also. So if you're putting in simple terms, UI is how an application looks and UX is to know where to place the buttons or where to place the call to actions. So if we're looking into this example, you can see that where to place the pause buttons, where to show the duration of the song and how much duration has passed, and where to show how to minimize and what all. These all factors is governed by UX. So this is just a brief this which I wanted to show to you guys. So right now till now, are you guys feeling bored or something? Just feel happy. Just tell me. So what is the current scenario? Like, did you guys understand something? Just taking a feedback from your side to get your user experience of the sessions up till now. So please do share. Do you have any doubts until now or any confusions, or did you understand the concept of UI UX of the UX? If you did understand, just give an S so that I can proceed. Okay, great. Okay, so now let's go. I will not boring you with boring theoretical, presentations. Okay, so I'll just show you why we need to focus more on the UX parts. Okay. Hello?
Hack பண்ணணும். யார் hack பண்ணா? எந்த system hack பண்ணுவா?
Sweta, you are unmute. Okay. So yeah. So how people have changed. Okay. So that is our next concept which we are gonna look. So before the let's say before the social media era. Okay, that is before 2008. What was the attendance span of us people? Hmm? it might limit to around 20 seconds. Okay, our attention span was 20 seconds at the first graph, or else we have to, like focus ourselves. But automatically, our human body was, focused on to keep that into our social media. Before social media, our attention span was 20 seconds. But after social media, currently we have 8 seconds. There's a common myth that our this thing attention span is much lesser than and golden fish. Okay, so golden fish attention span is theoretically they say it's 9 minutes, 9 seconds. I mean, like you keep a golden fish in a fish tank and go and tap on the finger of yours, and it takes 9+ seconds for the fish tank to ignore that and go to something else. And our social span has caused us to reduce our attention span to 8 seconds. So to capture these people's, to focus on these people's 8 seconds is what user experience mainly. So let's get back to prototype. So how you can prototype this? There are a few things before you get into prototyping. One is to know this basic concept. What is a wireframe? Wireframe is something that is just give a basic idea. Most of us might have an mobile application idea. You take your book and you're like, okay, this is how the place is going to be, and this is where I'm going to keep my search thing. Just give a basic outline, like just consider this as a human body, and the wireframe is going to act as lo-fi wireframe is going to act as a skeleton. Okay, then what is high wireframe? This is going to act as just before you add color to your design. Okay, that is what is going to act as high frame. That is like adding muscles to the skeletons, adding features like organs to the skeletons, etc. This is what high wireframe is going to be. And finally, the final design is going to be the skin. Okay, so that is what the final UI UX design is going to look like. So how we are going to design this? That is where Figma comes into play. Figma is a vector graphics editor and which is primarily web based, and it is no need to install. It is completely free as of now. Okay, it is free as of now. And Adobe, if you are familiar with it, Adobe has acquired it, and let's hope that it stays free. Okay, so even education plan exists for us, and we have all the perks of pro plans. So I'll tell you how to take these education plans and etc. Okay, and this is how Figma is going to look. Okay, not just UI, you can even start doing presentations also in these things. You can do presentations, you can design your logos, the design scope is phenomenal, and it is unlimited in Figma. So let's get started doing Figma. Okay, let's get Figma. So yes, so are you guys familiar with Figma? How much of you over here have Figma accounts with you? Okay, Meghna has. So yes. So if if those who don't have also tell me. So if the everyone has a Figma account, so no need to waste our time. Like saying how to take one. So if you don't have, please do give your suggestion. Just inform me. Okay. So I don't have. Okay, fine. So let's do one thing. Okay, how much of you have the education plan for Figma? Okay. Okay, fine. So, okay, let's do one thing. I'll share a link to you where you can get the education plan. Okay, Figma for education. I've shared it in the chat. So one second.
Yeah, it seems like only two of you are responding. Like, what about others?
Yeah. So have you guys got the Figma link? So I believe I've shared it right now. Okay, my audio is not clear. Okay. Okay. So I'll just share the screen on how to take Figma. So yeah, I've started sharing. Hope you can see. Okay, so this is the Figma Education and the Figma tools. Like everything is free for students and educators. This is go to get verified, and I have actually I have already verified myself. Here's I'll show you. Okay. So inside get verified, first you have to log in. Okay. So if you are a new account, just create one. Okay. So creating account is so free. You can either continue with Google or you can use the email and password and create an account for yourself. Okay. Next inside get verified. Let's do one thing. I'll show you with my some accounts. Yeah. So this will be the first pop-up. So they'll ask you what you're doing. Okay. So you are a design marketing user. Just say design. Okay. For teaching or for personal use. Okay. Then just create an account. Okay. If those who haven't created an account, so this is the first time me creating an account for my secondary username, and you'll get into this thing, get free education plan for your classroom. It's simple, hassle free. Just say that you're a student and just give a reason why you're applying for. Just like keep it crisp, because I want study. So just list your the school is listed. Just say list, like you can search if the colleges are listed. If not, school not listed, and school not listed. Just just say your uh, school's name. Just enter your school's name and just give your school's website. Okay. And what do you study? Just give your information. Okay. And when do you expect your graduation to be? Okay. So yes, I agree. Submit. So yeah, that is simple as that. Your education plan is approved. There is no verification also. Your education plan is approved and you must have received your email stating that. Okay. So just go to Figma and this is how your landing page shall look like in the beginning. Okay. So this is just basic this thing. Okay. So yeah, I hope everyone over here, has their laptops with them. So it'll be good if you guys, open your laptops and do the steps. And if there is any doubts, do mention. Okay, so I hope you guys I'll give you around, let's say, how much minutes do you want? Okay, let's start our next thing at within 3 minutes. So until then, you guys create your account and just ping me if there is any issues with creating the account. The first step is to log on into Figma, the link which I gave you. And if you're new to Figma, just continue with Google and select one of the email IDs and just fill the basic information. And post that, you'll get a form for the education plan and fill those. Like you try to give the information true as possible, as much as possible, because now they'll give you early access, but soon they will start like verifying it, and that time maybe the education plan shall be blocked for you. So yes, I think we can start. Okay. So now I will share with you a a Figma file. Okay, so that we can start working together. So one of the advantages of Figma is that any number of people, since it is an education plan, any number of people can work together. That is one advantage of Figma. So I hope you got the link, right? Figma files link. I just want you to click on that link and start joining. Yes, we have Muthu with us. Muthu Meena. Just join the Figma file. Yes, we have one more person. So, am I audible?
Yes, yes.
Yeah, okay, I had a network breakdown. Okay. So, yes, we can get into. Okay. So, there are 4 plus 3, 7, 8 people who joined us. Okay, great. This is how Figma. So, I hope you can see other people's cursor also, right? So I'll just start presenting and I'll show you how this looks. So, is this visible? Is my screen visible? Yes. So I would like everyone to come over here and see how the cursor looks for everyone else. Okay. So this is how the cursor looks. Right. So let's get into basics of Figma. Okay. So everything, whatever you see, the designs, etc., even the Google Meet, I mean not the Google Meet, WebEx Meet you're right now in, that everything can be designed in this Figma tool. So I'll just show you how to use. So let's come to the topmost corner of our Figma. Okay. So this is called as a toolbar. So toolbar, as a name suggests, this is where our whole tool is gonna be located at. Okay. So starting off with the very tool that is over here. Okay. The right, the move tool. This is the move tool. So this is just the cursor which is going to act as our main element over here. Okay, so that is our main tool. There is nothing you have to do. And if so, you have a scenario where you have to move the things, you will be using this thing. And next is where the why this is where the layers tab is going to be. There's no need to be worried about the names and all, etc. Okay, this is where the layer is going to be. And at the right hand side, we have the properties tab over here. Okay, we have the property tabs over here. So this is where all the properties are gonna look, the design, the prototype, inspect, everything is gonna be over here. Just keep this in mind. And this space is where you guys are gonna design. Okay. This is called the workspace where you are right now. That is where you're gonna design. So hope that is clear. Okay. And we'll get a basic more into a basic idea when we start designing. So let's start designing. So for every design, we need a paper, right? When you're writing something, when you're drawing something in physical world, we need a paper. So paper, or we can call them as canvas, right? So how we're going to get to the canvas? Canvas is over here. And in Figma, we call them frame. Okay, frame. Just hover over the tool and you'll get the name for that frame. The frame is where we're going to design. And whatever you're going to design inside the frame is going to come as an output. Okay, so this is one page, or this is going to be one frame for you guys. And frame size can be decided from there. So when you click frames, on the right hand side, you can see over here different phones. So for phone, you click phone, you have iPhone 14's design size, you have what else? You have iPhone 14 Pro, you have iPhone 14 Plus, etc. Then you have even the tablet designs. Then you have the desktop designs. Then you have presentation design. The frame for presentation. Then you have for the watch, paper, etc. So this is how the Figma's frames are gonna look. And you just need a custom size. You just need to select and drag and leave. Okay. So select, drag and leave. Select, drag and leave. So whoever is on Figma right now, I would like everyone to go onto the Figma site page and select the frame tool and draw some frames over there. Yeah, okay. Gokul has done it. Great. Now go to the Figma page where we are right now and just select the frame tool. Top most, you have the frame tool, just select frame, okay, and just draw, select and draw. Okay. If you have any doubts, do feel free to mention. Yeah, great. Yes, that's good going. So yes, we have scrapped the first thing. You can now design a frame. Okay, so frame is done. This is how we are going to work on. Let's get into iPhone. Okay, let's get into this frame number 6. Okay, this is where we'll be talking or listening to other designs. So frame is done. Now we have the next tool, the rectangle tool or the shape tool. Okay, this is the tool where the shapes can be found. Okay, just over here you have the frame rectangle, and you can drop down is available, and you can find line, arrow, ellipse, polygon, star, etc. So let's select the rectangle tool. Okay, rectangle tool as a name such is going to give you a rectangle shape. And the same property of how frames you have placed. You can drag and drop and clip. Okay, so the required size, etc. you shall receive. Now you're saying to me, I want an exact dimension. I mean, like 150 into 200. I want my width to be 150. I want my height to be 200. So how do we do that? That is why we have the property tab on the right side. If you can see this, this is where the transformation or the color or the reflection, etc. Everything can be controlled on the right side. That is the reason we call them the property. So what does this X and Y means? X and Y means nothing. They're positioned in the frame. So X is right. This shape, this rectangle tool is right now at X 15 degrees and Y to 18 units. Okay. So you can adjust that. Or just drag and this drag over here. You can see the variations in the panels. That is one thing that I would like to share with you guys. And the next thing about this thing is you want to give the size. That size is, let's say the width is 202 right now. You want the width to be 300. Okay. So yes, we increase of 300 and the height to be 50. Let's say 250. You get the height to be 250. My question is, how are we gonna make square? So anyone, feel free to give your comments. You can go to the comment box if you can create a square and just show it to me. So somebody just change the color. Great. So the way you're going to do square is there are multiple methods. Okay. There is no reason that you have to only follow one methodology. There are 2 or 3 methods. The first and easy, the most simplest method is simple in the sense like without any logic, without any complication. That in that methodology, if I'm saying simple, it is like go to with the format and what's the basic principle of being a square. The width and height is same. So width is going to be 300 and height is going to be 300, and yes, boom, we have the square over here. The next thing, but each time while designing multiple squares, you can't ultimately go and change the height and width. So there is another tool. There's tool is nothing same as rectangle, but right now just look at the presentation. To be honest, I'm gonna draw square right now. Okay, it's a perfect square. No matter however I do, I'm drawing a perfect square. So how did I do that? So that is the next question you guys might have. I did nothing. What I did was went to the rectangle tool, selected them, and rectangle. What we did, we select and draw the required size, then live. What I did was I selected, I creeping it selected, then I'm giving it a press shift key also along with it. So again, if you press shift right now without leaving the right click, uh, left click, you will get a square. Yes. So again, got and lift, then leave the shift. You have to lift the left click, then leave shift key, then you get a perfect square. So again has mastered it, and the square also somebody has done over here. You are doing guys greatly. Okay. This is the most easiest way to get a square. Anyway, okay. So in Figma, the most used tool you have mastered, okay, right now, about 80% of Figma by just having the frames and the rectangle tool. Okay. So the reason I'm telling you this, with the same, now we did two shapes, right? You did rectangle, you did square right now. Now I want to give you another tool with this thing. Let's tell me how we are gonna create this thing. Like I would like everyone to come and see my screen right now. Come out of Figma and shift to the meeting tab, and I like everyone to see this. So it's going to be very amazing for you guys. Look into this. So this tool right now, what I'm going to do is I'm going to give a, now the border of this thing is very edgy, right? Very sharp. Let's say we want a curved, border radius. What we're going to do is while you click this object, you can see over the right hand side, like width and height, you have this angle tool over here, rotation, just hover it, you can rotate it, right? And similarly, you have on the rightmost side edge tool. So what you do when you hover over it, it says corner radius. So over there, you're gonna just change the value and see the radius, corner radius over here getting into its curved field. Just change the value. So you want now, yeah, yes, you have done it great. And that is one way of doing. The next easiest way is again, you can't go over there and change, right? So there is this shortcut over here. You can see when you press the tool, I mean, when you press the rectangle object, you can see the on the corners, you see a small dot. Just select that and just increase and reduce, which ultimately we can reduce and we reach a point where it becomes circle. Okay. So Google is doing it right. Okay. So you come to a point where you go and reach and reach and reach. Ultimately, it becomes a circle. So to become a circle, we need a square. Okay. If it was a rectangle, you will get some other sphere, etc. Now comes the rotation. Rotation, again, there is two methods. You can go to property tab and give the angle, desired angle you want, or else just on the top right of the corners of the shape, just use this. Go over there, keep your cursor at the top corners of the shape. That is, for example, in mine, it is showing blue. For you, also, it show the blue outline of the shape. So over the outline, just go at the extreme ends and just do the rotations. Okay. So by this, you have completed around 90% of Figma. There's two tools I show you right now, right? One rectangle tool, okay, and one frame. And I'm saying to you, you have completed 90% of Figma. Okay, you can do 90% of design. Now the only thing that is left for me to show you to get you 100% of basic Figmas, or to do all the features, is just to introduce you to the text. Text is simple, just adding text to your design. So just text key, just use the shortcut key T, or just go over here and press the text over here, and you press over here, and you're gonna write something. So hi, my name is Salman. This is over here. So right now we have introduced text to me. Just go and select the text key in your Figma tool tab and type the design text you want, the place where you want, and start typing. So I don't see anybody using a text. So is it confusing? Okay. So yeah, right now my name is Salman, and yeah, there are somebody writing. Okay, Peter is writing hi, and who is this? Okay, everyone is doing great. Yeah, everyone is doing. Okay, thanks. Yes, that is how you write the text. Okay, now text again. There are different properties. When you click the text, you can see over on the right hand side. Okay, text. Right over here on the right hand side, property tab, you see text, and under that you have the font selection tool. You can select ultimate number of fonts over here. Okay, so uh, you can select any number of fonts. Okay, so you have the font selection, and I've selected font. Okay. So this is how we change the fonts. Okay, and next you have over there is the font size. Okay, you can change the font size as you desire. Okay, and then line spacing is the next thing, and this all you guys need to play with it. Okay, so design, the best thing about Figma is the more you play around, you see more design ways. Okay. So all I'm gonna do is give you guys the basics. Okay, so this is how you change the files in the font and etc. Now you're telling me you want to reduce the fonts like font size like me. Okay, see, I'm just reducing it simply. Okay, just by curls. Okay, just by using the scaling tool. So how do you access the scale tool? It is simple. Just in your keyboard, press scale. Scale gives you the ability to scale. Okay. So you can scale that as with the aspect ratio, the same ratio. And Figma recently introduced the scale. See, right, when you press scale, you'll have this pop-up with you. So you can, 3 times the initial size or 0.5 the initial size. You can have it by default. And from where it has to extend, from on this side or from the bottom side. It's, scaling 1% from that side. So this gives you an ultimate freedom to how to scale. So you have finally decided to add text to your design also. Now, this gives you complete 100% of completing the Figma design. And with this tools, you can design even the Figma interface right now with you. Because you have, when you recognize design, when you go to mobile application, just tap on everyone to come back to their meeting rooms. Okay, see their meeting rooms. Tell me which shape is prominent over it. Rectangle tool is the only shape that is probably over here. The meaning names, even the logos can be designed with the rectangle tools. So rectangle tool is the most utilized tool. From my 2 years experience, personal experience, and from my other UI UX designers or other Figma experts out there, even they say the same thing. Okay. So this covers the basics of Figma. Now, additionally, what is left, you may ask? There is, ways to make your job easier. Okay, I left out a simple thing, how to use colors. Okay, give me a minute. Sorry. Yeah. So yeah, I just wanted you guys to come to the meeting room, right? So you are in the meeting room right now. So tell me which shape is prominent. Tell me one shape. Like the whole black background is like full. The whole thing is rectangle, and above that we have some rectangle curved borders, rectangles, and even the mute button, start video, breakout sessions, etc. The outline is a rectangle too by having the curved radius. And logos, yes, how to create logos, I'll tell you. And almost everything is rectangle, right? So let's tell me, before I go into rectangles, boasting about rectangle tools, good things, I'll show you one more thing. If you master this tool, you are the master. Okay, that is how prominent this tool is for you guys. Okay. Okay, this tool is called the pen tool. See, Now you created a rectangle shape. Pen tool is something similarly giving you freedom to draw whatever you desire. Whatever you desire, you can draw anything. You can, it's simply like using the pencil. That is what the pen tool is exactly over here. So that is what the pen tool does. Now you will only give you straight line. No, it can even give you curved lines. Okay, like I go over here and you can see my screen is visible, right? You can see the pen tool over here on the right, top right, this thing. Okay, you press that and you can bend it. You can give a curved this thing. You can draw any number of shapes or anything with this freedom to, this thing. So with this pen tool, if you have mastered it, you're a master of design. Can draw anything, you can draw ultimately any number of things for you. Okay. So if you're asking me how strong is Figma, I can take you on a journey. How strong Figma is. I'll show you some videos that are done via Figma by using prototype. Okay. I can show you some designs that are done in Figma. Okay, so I hope my Instagram is visible. Okay, this is one of the clubs I had started my journey at. Okay, so the designs you see right now are entirely done in Figma. Okay, the designs you're seeing, etc. And I just want to showcase to you one of the prominent this prototypes that we have done. Okay, this is entirely done in Figma. Okay. So this is one design that is done by Figma. This is another done in Figma. So this is the freedom of Figma when you master the tool of pen tool. Okay. So there are more, inspirations which you can see. This is just giving you a brief idea, motivating you guys that Figma is capable of doing all these things. Okay. So I'll give you one more tool which I missed. That is how to change the colors. And this is over here. You just go to the fill over here, right hand side, and choose a desired number of colors. Okay. You can choose any desired deciding factor of color. Okay. So that is color number one. You are like, okay, I don't want a solid color. I want a linear color, okay, like gradient thing. Like gradient is like, the trendy all. Just go to the fill, and on the top right, you have the options: solid, linear, radial, etc. So linear is the gradient which you're looking for. Okay, so this gives you a gradient. You can like adjust from where it should start, what color. So this, I want it to be black, maybe blue, and this, let's say it wants to be red. Okay, so this is how the gradient works. So that is about gradient, and that is about colors. Now there are multiple, again you can exploit so many things. You can do so many, have so much more freedom. Like, let's say, add some image. Okay. So that is where plugins come into effects. Plugins makes our life more easier, and that you can find it over this thing, resource tools. Just go to resource and go to plugins and search. Okay. So Unsplash is one of the tools which helps me to get, images. So I search and yeah, I get people's photo and it gets pasted over here. Okay. So this helps, to design. So I want to add this image on this shape. So somebody has created this as a component. Okay. Control Shift C. Component is a, kind of a heavy topic, and I wouldn't be covering this at this time because it'll take another 1 hour to explain the benefits and the big use of the components. Okay. So yeah. So let's say I have this shape over here. Okay. So, okay, I'll explain to you really what a component is, okay? Right, copy, okay, okay. This is a component, okay? I'll give you a basic idea. Whatever I change here will change in the next object also. Okay, so the main use is like when you come back to our meeting design, like you can see that the meeting name which has written is unique. It's not unique. Like my name box is similar to everyone's, the rest of the participants' names. So let's say I want to change the design completely. So I want to reduce the border radius from 10 to give it an edgy look. So I have to go and change in every designs. But no, here I can just over here select and change the border radius. Eventually, the border radius also changes in all the design. That is one of the basic way of component and makes designing life easier. So that is one this thing. So anyways, let's get back into our thing. Let's say I am gonna add this image onto this shape, this particular shape. So this image is not at that dimension. So what do I do? So first thing is I go and place it over here and resize it. I'm gonna resize it. Yeah, I've resized it. Now what I'm going to do is I'm going to select both the shapes, and you can see here you just mark. Then come again. There is a shape behind you. There is a shape. Okay. You want to keep that image. So what you're going to do is place the image what you want to shape over there. Okay. So you are creating it on top of that shape. You're going to select both of them. How are you going to select both of them? You're going to select like this. Okay. You're going to left click and select both of these. And use this tool over here, use as mask. You select that, yes, you have used as that as mask. And now you have added that shape wise. Now you ask me like, what is this? You could have cropped it that way. Now I would like you to see, what if I wanted a star? Okay, star. I'm drawing a star right now. Okay, this is a star. And I can change the number of, shape. This is hexagonal, octagonal. I can do any number of these things. So I'm doing like this. And next, I'm again adding that image. I'm taking that image and I'm saying, okay, I want myself in the star. But I can't keep the star at ahead of me, okay? But I have to keep the image at front. To bring image at front, you have to do one thing. This is the layer tab, okay? Layer tab is over here. So this is the image. Where is my image? I've selected the image. I've located my image over here. I have to bring it at the top, above star. Okay. This basic concept is above star. Okay. That is one way of doing. Another way is right click and bring to front. It automatically came on the front. Okay. So you select both of them and use as mask. Now it is inside the star. So yes. So we have shot our 30 minutes, our second session on Figma by 6 minutes. So I have explained to you almost all the basics of Figma, and I would like to hear your reviews on that so that we can get back into our prototyping. So yes, do tell me your, okay, there is some chance. WhatsApp group, yes, yes. So any questions, any queries? And how was it so far? Was it entertaining or was it boring? Please do suggest. Anyone? Okay. So I think we shall move to the next one, next module of our presentation. Before that, let's have some fun sessions. Okay. So let's not, bore you guys. Okay. So let me do some fun sessions with you. Hope my screen is visible. Okay. So now what I'm going to do is I'm going to introduce you to the world of Figma. Now, Figma is not just work time. Okay, Figma is like fun. You guys will enjoy playing with Figma. So now what I'm going to do is let's have in real life. If this was an offline meet as a speaker, I would have come and said to you guys, okay, guys, let's the event was fun. Let's have a selfie before the event ends. Right. So that session might be there, but I'm missing that right now since it is an online event, and asking you people to on the camera through the meet is going to be very hectic. Okay, so and it is not going to be a positive reply. So let's do something else. Okay. So let's look for the camera photo booth. Okay. So what I'm going to do is this is going to act as the real selfie camera for us. Okay. There are 14 people among us, and this is the page 2. Okay. So Figma, you guys all are on page 1 right now. Okay. So how you guys come to the page 2? On the layer tab on the leftmost, you can see 2 options. Page 1 and page 2. So now you guys will reach to page 2. That is one way. And what is the next way to reach to page 2? Over top over here, you have so many options, right? So many names. So you want to follow me, just click my name. You can come to where I am. Now Aditya is in first page. I can see her. Then not her. Then Ariva, I can see he's over here on my page. And next, who all are there? Now let's see Google. Google is at first page. See, I can see where you guys are on. Okay, Sweta, where is she? She's at the first page looking for me. Okay, so okay, now she's in the second page. Okay, fine. So this is how you look. And the next thing is the tab over here on the pages tab on the top left. You have pages. Most of the time it will be, drop down will be there, and user drop down. Okay. So yes. Now that is one thing. Okay. Next thing is, how do you chat? I want to chat in this. Hi, my name is Salma. Okay. Now I could chat and I can send this message to everyone. It is there in that place and everyone see, and it is visible for them. So this is nothing. You just use the forward slash. Slash is actually button you to the shift, the rightmost shift, like the question mark, etc. is there. No, that place. So that is where you just press that and start typing. This button. You just press that once. Yeah, hi everyone. Sabir has done it. Sweta has done it. Yeah. So that is how you chat in Figma. Like your team is there. Like how is this useful for your hackathon? Like your team is there. Okay, so your team is trying to talk to you, but Google Meet and everything is very hectic. You just go and you can use it and be here. And again, it is not just if you want to have conversation. I believe since you're in education plan, you would have this start conversation on next to your names. So you just use that button, you just click that, and your name will be visible. Okay, you'll be in a meeting with other people. You click that. See, I'm now in a voice connected. Okay, so hi, and if somebody else is over there, if you can join the top left over here. And since an education plan is only it is available, so I believe it is there only in that. Okay, so you can talk over there and chat over there and have a collaborative place also. Now back to our gaming area. Okay, so yes, this is how we're going to game over here. Okay. So we are gonna take a photo. Okay, my camera is kind of loosey. Okay, so I can't. Okay, my camera has an issue. Okay, so yeah, so the photo will come over here as a photo reel. Select this thing, and the camera should have started, but for me, recently ran into an error. So 3, 2, 1, and click a picture. So if you guys need one, just go and click that picture and just choose your pictures. So come on, Sabil, you all on the red button over here. It is a click. It's clickable. The red button on the top left. So take photos if you guys could take some photos and just list it in this photo walls. Okay. So now what is okay? Right there. Okay, that is comment. That is Nibangshu Barik. So what you did over there is a comment over there. Comment is actually this thing, add comment. So it is like nobody is like, for example, your team member, let's say my team member has designed one design. He has left it, he's not online right now. So I say, hey, this design is cool. But can you make it green? They're just saying him, okay, bro, your design is nice. Just will be great if you make that design. That is a why comment is getting utilized. So with this, you can play around with your friends. Like what we usually do is like before the meeting, how I look very happy, and after designing for 2-3 hours, I'm getting so much review changes and how I look. And we just paste it in the walls, and that gives us, it is very interactive to be with your friends in such a manner. So that is one thing. So yes, so let's get to the next part. Or when do you want to have the prototype? So just give your suggestions. Audio not clear. Is it clear right now? Okay. So let's get into the prototyping, and I'll just design some 2-3 designs for you. And we can just design one screen, two simple screens, and start prototyping. And I would have loved to design them in real life to you guys, but right now since our time is very limited and it's already, I believe, 7:14. It's 15 minutes with us. Okay, so I will just show you one small login screen design, and we can shift to the real design and how we can prototype. Give me a minute. I'm just plugging in my charger. Okay. So everyone, let's you have your own page. Okay, let's create a page. So I hope you guys know to create a page. Let's go and create a page in your name. Okay, so I believe we'll have 5 to 10 pages since we have around 12 to 13 people over there. And in that page, we can start designing a login screen. And I'll show you how to design a login screen without much hassle. Most of the time we are in a scenario, we are in a place where we can't get inspiration and people are scared to get inspiration. There is inspiration and copying is two different things. In a design life, there we have to take inspirations a lot because the world, how was flight created, aeroplanes created? There's a bird called flamingo, I believe, and that is how they got the inspiration of taking off and landing. That is how aeroplanes were designed. So as such, we have to take inspiration from nature. We have to take inspiration from other things, and utilize it in our designing life. So the best, to get digital this thing is a site called Rebel, and for just digital wise. Okay, so see, beautiful such designs, etc. can be there. So I just go over here and start typing login screen. You will have this much multiple, interfaces. Like you will have an basic example, like creative ideas. Like these you rarely see, and these designs are very, creative ones. So this helps you guys to have a basic idea. So see, this is such a beautiful, clear design, and it requires you to sign in. Just sign in. Give me a minute. Okay, so where did that login page go? Okay, I think we missed that beautiful page. Okay, anyways, you can have any number of login pages. Okay, you can search for login. Yeah, so you can find. Okay, let's do one thing. Let's try to recreate this shopping image. So we go to our Figma. Where is the Figma? Yeah, over here. So I'm gonna do it at page 3. Page 2. Okay. We're gonna use this design. So how we're gonna do? I'm just gonna do it very first. I would like everyone to see my presentation. So I'm gonna, either select this or go to the frame. Say I want a desktop size, and then let's go for MacBook 14 inch. Next, there's this, rectangle over there. So there's a rectangle tool over there. So you can just cover half the screen with the rectangle tool, and this helps in placing. Okay, so half means over here and middle. Yeah, so yeah, this shall work. Okay, next the color selection. Color, yeah, color selector. I give it the color, and these two colors are actually, maybe a gradient or something. So since it takes some time, I'm just gonna randomly do some colors. Yeah, and I'll give it a radial blur. Okay, the radial. This is also this. This, yeah, this might look okay. Okay, okay. I'm gonna expand it, and this is over here. And the next color over here is gonna be pink. Okay. Okay, we didn't get the perfect match, but we did get some matches. This thing, maybe that is glass morphical. Another designing trend. It was very famous recently. Okay, so I'm gonna use that. I'm gonna give it a white color, but I'm gonna reduce the opacity. Okay, so yes, I got a this thing, a shape like almost that similar one. Okay, now I'm just gonna type digital digital platform for distance learning. And again, this is not the format. This is my favorite thing, like font. So let's use other font. Okay. So, platform for learning. And obviously, this is not the font they are using. And we'll just try to, resemble. Okay, now that is there, and we have given it a bold feel. We'll make it bold, and for distance learning is in a different place. Or was also in a different place. So we are trying to just recreate them. Okay, recreation shall help you guys in for designing in multiple ways. So this will give you and familiarize you with multiple tools, because I learned most of this by recreating. Okay, so yeah, this is there, and we can just give it a white color. Okay. And let's say this A there. A, okay, emojis. You can insert emojis also. It's not a big issue. Then you can have enter the information you entered while registering, right? Registering. Okay. Can be anything. Okay. And again, you have to reduce the weight. The weight means it was light. Okay, regular. Okay, and it was in a complete one sentence. So you can also try to do that one sentence. Okay, and that is there. Now email and this thing. And how do you do that? Again, tool, email box. Okay, you give stroke. Stroke is what they've given outside. So stroke is something that you give while giving the outside shape. So just give stroke. I'm going to give this color and I'm going to remove the inside shape and give some border radius. Okay, so yes, Eureka, we have done it. And email and oh, my bad. Control V and maybe phone number also. Okay, so this much information is here now. Now, okay. Okay, and we need this radio buttons. I'll give radio buttons, no problem. We have time. Okay. Okay, now what is there? It is blue color. Change the color to blue. Okay. Blue is there. And six is where the pen tool comes. I said, right? You is the pen tool. And yes, you have done the tick also. And you bring that the design. Okay. Tick is there and you change the color to white. And since this is now, I'm doing this very fast, it won't be perfect. Just stay with me. Remember me. The text, remember me. Remember me. Okay. Now pose that you have forget password and etc. So just create that gradient effect also. Okay, gradient effect. Gonna fill this time, remove the thing, and it's actually gonna be a gradient of multiple, but still we'll go for linear this time and from left to right. So left to right means I have to align this. So on the left hand side, we'll have this light shade, and on the center, we'll have this dark blue shade, and on the right hand side, we'll have at the end this purple violet color. Okay, I believe we have almost captured this. Okay, and you just can play with this thing to get the correct exact, tint. And again, log out. We log in. Okay, so this is a basic login page. Okay, we designed it so fast, maybe 5 minutes. This 5 minutes just what look like. Okay, more time we could have perfected it more betterly. So anyways, my concept was not to perfect this, but to give you an idea about how we have designed this thing. And now let's say this is a design number 1. Okay, and after logging in, I want to say over here, okay, like, hey, thank you for logging in. Thank you for registering. This is what I want to show over here. So on basic, to like we're conveying what we're conveying over here is like, okay, so to a person, you're going to show them like a presentation like this. What if I showed you a presentation not like this? Okay, not like this, but rather like this. Okay, go to Figma. 1 second. I'll show you the file which I worked that presentation on. That presentation was designed on Figma only. Like instead of showing you that prototype, instead of showing you with those animations, I just showed you like, okay, slide prototyping with Figma, second one, why Figma, the third one, how to prototype, what is UI, UX, etc. Would you have loved or would you have liked it? That is my question to you. No, right? So the issue over here is we are going to present it in a beautiful manner over here. Like this is number 1, this is number 2. Okay, so how we are going to show it to them? So that is where prototype comes. And Since the beginning, the file, there has always been a guy who's hidden over here, the number one culprit over here, and the number two culprit over here, the play button over there. So these two are our prototype tools. So you click the prototype, you have the new things. Okay, so you open it, and this is how it is going to. So you're going to click the screen. This. So how you're going to do, what you're going to do. So when you click the screen, as soon as you hover over the frame, you can see so many plus signs over here. 4 plus signs in 4 different corners of the frame, and inside plus signs. For each button, there is a plus sign. So what is it used for? I say I press the login button. I want it to go to the next page. Okay, now let's create another button for here also. Now maybe that button shall say go back. Okay, the button shall say Control X, Control V, go back. This button is going to say go back. Fine. So that button, while I press, it should go back to this design file. Okay. So basically what I've done is I've done basic prototype. I select this. Okay, this is how the prototype my app is going to look like. I press login, it goes to this thing. I press go back, it goes to this thing. It gives you an interactable design. That is a basic concept of, this is the basic of the basic concept. And this you can play around and create multiple scenarios to create like videos, which I showed you. And how you're going to create, I'll show you a basic example. I just have 2 minutes with me. So anyways, I'll take some extra time. Okay. So what happens is, right now what I'm going to do is, let's say, let's create another design. Okay. Okay. So what I'm going to do is, I'm going to show you some animation with the how I did this animation. Like, see, this is like jumping, right? Prototyping with Figma, it is like keeping on jumping. So how we can do similar such things? Okay. So that is nothing. No need to. This is not, rocket science. It's just simple. Okay. So go to design. First design frames like this. Okay. Hey, hello there. Let's make this, jump a bit here and there. Hey, hello there. Text number one. I'm gonna copy this frame. Control C, Control V. And all I'm gonna do is I'm gonna select both of these, and I'm gonna just create an upward motion over here. Okay. That is one motion that I'm doing. Okay. And I'm gonna go over here, select prototype, give the connection where I want it to go over here. Now this pop-up is going to come on my right hand side. So this is the where we're going to debug everything. On click, no. After delay, I click after delay. After delay means over here what I did was when I press this thing, only it moved to the next slide. So they're asking me what should I do over there? Like so by how should it go to the next slide? I'm saying after delay of 1 millisecond, it should go to the next slide. And what is the animation I want? Just click smart animation. Okay. Ease in and out. Let's say 900 milliseconds. And up here at the same time, I want to go back to create a loop. Okay, it's going to create a loop. So I'm going to click this slide and back it over here. And I'm going to copy the same thing. Like after delay, 1 millisecond is in and out, and 900 milliseconds smart animate. So what is going to happen over here is there's a different flow. Okay, see, it's jumping now. Hello. So yes, this is how futurely you're developing, and you create different animations like that. And now the next thing, now it is just a basic screen, right? Now you are saying to me, you want to present it as a laptop screen. Go to prototype, there is an option called device over here. You select, and for this instance, this is a desktop version. We're going to say we're going to have an Apple MacBook 14 Pro because it is designed for Apple MacBook 14 Pro. So you go back to our design and see you have right now fit to screen. Yeah, see you have a MacBook. You log in. This is how it's gonna look. Okay, this is how this is gonna look. So yes, this is basically what prototyping with Figma actually is. So this is what I just wanted to convey with all of you. So yeah, this is prototyping with Figma, and this is what I wanted to share with you. This is just giving you an initial push for you guys to, I've shared everything that you need for this hackathon to crack this hackathon. Okay, you can build so many things with this. In future, you need any more, complex this thing or something, you can contact me. You can find me in LinkedIn. Salman Faris is the name, and Instagram too. You can find me. You can connect me through WhatsApp. I share my numbers, and yeah, this is basically it. Um, Shaheen, Vikram.
Yeah. Okay.
Yeah, yeah. So yeah, if they have
Okay. Yeah.
any
Thanks.
questions, we can go to the Q&A, and or else we can wind up.
Yeah. If anybody have something to ask.
Mm, so yeah, that's it, guys. Thank you so much. So yeah, let's connect soon in some other place.
Yeah. How was the section? Like, can someone tell any feedback?
Yeah, yeah, that'll be great. Okay, thank you, Sabir. Thank you so much. So only Sabir liked my session, nobody else.
Yeah.
Okay, Darren. Thank you. So yeah, guys, thank you so much. So
Okay.
okay, Shine. Thank you.
Yeah. Okay. Okay. Bye.
Bye.
So next we will have Jojin like explaining about hardware prototyping. Like now we have covered the software prototyping, right? So Jojin, are you here? Oh, just a minute.
Hello. Hi.
Ah, okay.
Okay. Are we good to go?
Yeah, I think we can go. Yeah. So for your information, like so by today evening, you have to start building your product or like ideating your product and all. And anytime you need any vendor connect or like connect to any vendors, you can a form will be shared to you. You can book a time slot in that, and you can connect to whoever you want. Okay. And by tomorrow morning and evening, we will have some review session. Like we will review your like current progress and all. Okay, by the end of day after tomorrow, we will end to a conclusion. Okay. Yeah, hope so. Yeah, we can start, right? The hardware section.
Yes, yes.
Okay.
Okay. Hello. Hello, Shahid.
Yeah.
Okay. Can you see
Yeah.
the
It's okay. Yeah.
suggestion? Okay. All good to go.
Yeah. Good to go.
So,
Yeah.
good afternoon, everybody. So I hope we have discussed about few of the concept I am talking in the initial phase during the design thinking discussion. So a software and a hardware prototypes, even though both are prototypes, there are certain significant differences in the prototype. So, but some of the tools, for example, Figma, just learned prior to this session. So these tools can be universally used for any sort of product or prototype development in order to curate idea, in order to deduce understandings in your learnings. And the only difference is that whenever you have to fabricate or create something out of the computer into the physical world, you need some sort of physical tools and be capable of translating that digital idea into a physical concept is required. So what is basically a prototype? From any understanding, a prototype is a functional version of a product which could be used for testing, feedbacking, or introducing to investors or any other sort of requirements. So a prototyping process is actually, we are actually exploring a multiple ideas in order to figure out a functional medium which can be used for further development of a product. So the advantages of having a prototype is you can save money as well as time other than directly going for a final product. So these are some prototypes of some objects. So on the first, you can see a clay model of a vehicle. So a car can be prototyped as a clay model, which can represent the design aspects of the vehicle, and also it could be used for some aerodynamic or testing and appearance testings also, lighting testing, and how the reflections will work on the vehicle dynamics and sort of things. And on the next, there is a paper prototype of a furniture. So, which is again actually testing the usability and the appearance, aesthetics, importance of the furniture. So, in order to check that, we need not have to develop a full furniture. So we can just try on a paper or something. So on the next, you can see a robotic arm, which is prototyped with a 3D printed parts and a few motors. So, hello? Any questions? Okay. So the next one is actually electronic circuit is prototyped with a PCB fabrication board, and you can prototype the electronics components in this modular manner so that you don't have to, prior to taking some effort to fabricate a commercial PCB, you can try out in a breadboard or something, and you can figure out whether the components will work in the specific combination in order to get the output we are expecting. And on the bottom, we can see a sketch of a product which can represent the physical appearance and the usability of a aesthetic appearance of a product. So which can be used for further refining of the product, and in order to creating a CAD model or a 3D printed prototype, these sketches can be extremely useful. So on the last one, we can see the prototyping stages of a Dyson vacuum cleaner. So you can see that in each phase, the product is actually a completely working prototype, but they are each iteration they are added more details and refined it into a more appealing and usable product. So the prototyping is actually the fourth stage in a design thinking process. So we need to prototype and we need to test the product in order to refine into a complete product. So usually people get confused with the prototyping and production. The prototyping and production models are two different models. Even though both appears to be similar, the prototype is the final functional model of an actual object which can be produced in mass quantities. So a prototype is, it can be confused with a final product. So I'm specifically saying it from a perspective of a hardware background. So I hope we have seen that video. So basically there are 6 types of prototypes. So these are depending on some certain understandings and classification. So there are different types of prototypes also, but generally we can classify them into 6 broad categories. The first one is a concept stage. So here I'm actually using an example from the car manufacturing industry so that you can relate into something you are already familiar with. So a concept sketch can be considered as a starting point for a product prototyping journey. So you are arranging certain design aspects, and considering that design aspects, you will be drawing some basic models which can rarely represent the actual product, but eventually it will evolve into something very useful and similar to the concept. But these are early sketches which will be used as a benchmark for the further prototyping journey. So a concept sketch of a vehicle will be look something similar to the first one. And the second one is bench model prototyping. So the bench model prototyping can be considered as a subsystem testing, if you consider something like that. So it's a module testing process. Suppose for an electric vehicle, there are multiple modules will be combined into form the actual vehicle. There will be drivetrain and infotainment system and the interior space designing, vehicle management unit, all sort of these things will be available in the vehicle. But during the bench model prototyping, you will consider each one of these individually, and you develop a prototype which can rarely satisfy that specific function. For example, a bench model prototype of a vehicle can be a drivetrain which consists of a battery management system and a motor coupled with a gearbox, or it could be a gearbox and motor itself could be considered as a bench model prototype. These are subsystems which these modules could be integrated into form a complete vehicle. So that is called the bench model prototype. So the next one is fully functional rapid prototypes. So these prototypes are complete integration of the bench model prototypes so that the individual modules will be combined into a single product which can satisfy the minimum requirement of actual product we are expecting. So this could be considered as a Frankenstein model of installation. So none of these parts may not be used in the final project, but it can achieve the expected outcome of the product we are actually expecting. So these will be standard inventories for this. So there won't be much custom parts in this stage of prototyping. The motors and batteries, everything will be sourced from standard vendors. And this can be rarely satisfy the function of the actual expected model. So an example in electric vehicle, which would be the tire will be from one company and the drivetrain will be from a different entity, and this will be integrated into an old Volkswagen or Mercedes kind of car, so that it will prove the concept that an electric vehicle fabricated by this means could be worked in an expected manner. So this is actually a Frankenstein kind of model. So that's actually called the fully functional rapid prototyping. The next one is the visual model prototyping. So during this stage, we actually rise into a point where we are defining some properties depending on our specific requirements. So during this phase, we optimize the shape and appearance, aesthetic qualities of the vehicle expected with our particular outcome we are expecting. So the clay model and the CAD models will come during this phase of prototyping. The next one is the pre-production alpha prototype. So these prototypes are almost similar to the final prototype, but provided these are for extensive testing. So during this phase of prototyping journey, we may not be able to change a massive change in the prototype since we already finalized certain aspects of the machine already. Sorry. So these will be used for crash testing or user feedbacks and for the final refinement of the product. So that will be the pre-production alpha prototypes. The manufacturing prototype is actually a modified and refined version of the pre-production alpha prototype, so which is optimized for mass manufacturing. Even though the manufacturing production prototype fabricated in a different way, but it will be optimized for mass manufacturing. So in order to fabricate the pre-production alpha, you need some specific kind of machines. But for the manufacturing production prototype, it will be produced with the actual workflow where we are actually implementing or we are planning to produce the actual production process. So these are the 6 different prototypes. So you can relate within these prototypes in any scenario. I just used the vehicle industry as an example. For the mobile phones or electronic circuit, anything, this is relatable. So you just bother about the concept. You don't have to bother about names or the specific project I mentioned. So every prototype should travel to these 6 phases at some point in their product development journey. So I hope I shared this. So you don't have to worry about where you actually started, but you will be ready to adapt to the changes and always looking for opportunities to betterment in order to settle into a more meaningful design. So I can share you a quick video. So this is actually a product development journey of a robotic arm. So he actually started from a paper prototype. So you can see the timeline. He's actually started in 2018. It's eventually getting complicated with each iteration. It's actually taking feedback from the actual users who's going to use the product. So after he gaining certain confidence, he actually started a company. These are the first prototypes, and this is the final result.
Always be a good boy. Don't ever play with guns.
So by conceiving small steps, you eventually lead to your desired outcome. So that's it. So even though you are taking small steps, but these things will be, if you are choosing the direction rightly, eventually you will get into a point where you have a valuable product in your hand. So we always develop in spirals. So the spiral development is a project management ideology similar to agile and lean waterfall kind of things. So the spiral is a methodology which is majorly accepted in the product development, especially hardware product development cycles. So in each iteration, you have a fully functional prototype. So if you look on the top image, you are actually seeing a 3D printer, which is fabricated by a company called Formlabs. Each of this is a iteration of a product. So the 3D printer is actually a resin 3D printer. So if you choose any of this product prototype, each one of this will do the resin 3D printing process. So this is actually a complete product in itself. So what they are actually doing is that they are actually refining the shape, usability, and user interaction in each iteration. And they are adding more sensors and actuators so that this process could be made easy so that people with less technical skill could also access the device. So the spiral development is actually, we are actually identifying a problem and we design some sort of a solution around the problem, and we construct the model and we later evaluate the model. So this is a cycle in a spiral development, and we are actually going in spiral by improving our scope. So eventually, after completing each spiral, we will have a complete product, and after the last spiral, there will be a finished product. So one advantages of having this approach is that after each spiral, you will have a completely functional prototype, and this will give you some sort of satisfaction and confidence on your journey. On the other hand, the advantage is that if you are attempting the complete journey in a spiral, So at some point you will figure out whether it is possible or impossible to attain with the current capabilities of you. So we can quickly switch to a different project, or we can completely abandon the project depending on the greater understanding on the process. Okay. So rapid prototyping is actually, it literally means rapidly prototyping the product. So the rapid prototyping, these are all part of the rapid prototyping journey. So the design thinking and the prototyping, multiple stages of prototyping, this will all lead to a point where we have to prototype things in a rapid manner. So that is the significance of having rapid prototyping. So these are rapid prototypes of some objects. So this is a vacuum cleaner, and the SpaceX super heavy rocket is actually an example of extreme rapid prototyping in aerospace. So uh, when discussing rapid prototyping, we come across some tools which enable us to rapidly prototyping our design models into physical objects. So let's go. So these are the advantages of rapid prototyping. It reduces cost and it help us to get into market in a faster manner. And yeah, you can go through the slides if you want. I already shared it with the team. So there are certain things outside of rapid prototyping also. So 3D printing, digital fabrication, UI, UX, simulation, software. Other than this, we need people, infrastructure, all sort of things for rapid prototyping. So what I'm saying during this presentation is actually a small part of the rapid prototyping journey, usually about the tools and machines we can use for rapid prototyping and the approaches we can use for rapid prototyping. But don't confuse with this is the only uh, part of the rapid prototyping which is possible. So other than this, there are a lot of things included in the rapid prototyping work. So one of the greatest tool which could be useful for rapid prototyping is actually digital fabrication. So usually in fabrication, which we all familiar from the childhood, is actually a carpenter or a skilled person will actually make the product with his hand. So digital fabrication is actually the process of fabricating things with the help of a computer. So usually there will be a concept, and the concept will be translated into a CAD model, which is a digital representation of the model in a computer. And later we convert that CAD model into a CAM process. A CAM process is a instruction set which actually define the CAD model in a verbal manner. So I actually completing the descriptions, we could literally make the CAD model in a physical world. That's actually the CAM model. It's a computer aided manufacturing model. And then we feed the CAM model to a computer controlled machine, and this machine will fabricate the final product. So these are some kinematic models which could be used for different CNC applications. So these CNCs will include a CNC routers, laser cutters, 3D printers, etc. So basically a computer controlling a tool depending on the instruction we are providing from a CAD software. That's actually the digital fabrication. So these all are some examples of kinematic models. This is a Cartesian system. And this is working in the polar coordinate system. So instead of translation, the rotation of the arm creates a motion, and this is actually creating the output. So there are, oh, I'm sorry. So there are robotic arms also which can do the same thing. So this is actually moving a tool with the help of a computer. So simple. So we can use any kinematic approach to achieve the same. The process is same, moving a tool with the help of the computer. So if you consider a couple of digital fabrication tools, we can compare it side by side. The CNC milling is actually, we are moving a drilling machine or a milling machine with the help of a computer. So the kinematics will be same. It is a mechanism which can move a machine tool in 3 dimensions. And in the CNC milling scenario, we are actually using a milling machine. In the case of a 3D printer, we are actually using the same mechanism, but instead of a milling machine, we are using a plastic extruder. The plastic extruder will move in such a way that the extruded material will be deposited in a fashion we provided in the CAD model. In a laser cutter also the similar mechanism, but the end effector will be a laser source which can cut through any sort of material. So this is the process underneath the digital fabrication. Just consider a real life example similar to the Google map. So there will be a greater perspective view similar to the map which represent the starting point and the destination. And whenever we start the journey, it will be split into tiny instructions, just like go 100 meter forward and turn right. Similarly, it will be split into small instructions. And whenever we start moving, one instruction at a time, the app will feed us one instruction at a time to our user interface. Similarly, in digital fabrication, there will be a CAD model and it will be split into instructions. And these instructions will be fed to the machine one at a time. So thereby it achieves the desired goal. So just for example, even though we are not aware about the complete picture of the map, if we just follow the instruction from the map app, we can arrive at the destination without any greater understanding of the geographical information. So similar to the machine need not to have any understanding on the CAD model in order to follow the instruction. Even though the machines don't have any complete understanding on the CAD model, by following the instruction, it can attain the desired output. So basically there are 3 types of fabrication methods, which is additive, subtractive and formative manufacturing. So you can consider additive manufacturing as creating jalebis. So we are actually squeezing some material into the oil and we are actually creating some jalebis. Similar to this, whenever we are starting the procedure, there won't be any material on the build volume. By adding more materials, we are creating the product into the work area. So this is actually an example is 3D printing is an additive manufacturing process. The subtractive manufacturing process is on the other hand, there will be a solid material on the work area and we are actually subtracting the part we don't want. So the cookie cutting is an example. You are actually removing some part and you are actually creating the desired part out of the dough. So CNC milling is an example for subtractive manufacturing. And formative manufacturing is the process we are actually pouring the material into a mold and we are quickly making replicas of the material we actually want. So injection molding and chocolate casting is examples for formative manufacturing. So how do you choose the fabrication method? So you can the quantity versus the cost is an example. So the cost per quantity is an example for choosing how to choose the manufacturing method. So if you have low volume production, you should go for 3D printing. And if you have medium volume production, you can go for CNC machining. And if you are looking for large quantity production, you should definitely go for formative manufacturing. This is subjective to some specific application, but the common trend is something similar to this. So complexity versus quantity. If the complexity is high, we should go for 3D printing because the 3D printing process need not have any prior understanding of the complex, irrespective of the complexity of the design. The printer can fabricate any sort of mechanical structures. But for the CNC machining and injection molding, we should be aware about the complexity of the mechanism we are actually printing. So this is a graph, you can refer this. So next to digital fabrication. So some of the digital fabrication. So whenever I think about digital fabrication tools, this is the scene came into my mind. This is actually a scene from the movie Iron Man first, and the Tony Stark is building his exoskeleton, and he's actually assigning this job to a set of machines, robots, and they are actually fabricating this exoskeleton for himself. So this is actually an ideal example for a digital fabrication environment. So let's see what are the current tools available in market. So in order to do digital fabrication. So the most common digital fabrication method is actually 3D printing. So 3D printing.
What is 3D printing? 3D printing refers to a variety of processes in which two-dimensional layers of material are deposited and joined, one upon the next, to form three-dimensional objects. This process is also known as additive manufacturing and is a fundamentally different way of producing parts compared to traditional, subtractive, or formative manufacturing technologies. How does a 3D printer work? The 3D printing process always begins with a digital 3D model that is converted into an STL file. This model is then sliced by the 3D printer software into thin, two-dimensional layers and turned into a set of instructions, known as a G-code, for the 3D printer to execute. From here, the way a 3D printer works varies by process. For example, desktop FDM printers melt plastic filaments and lay them down onto the print platform through a nozzle. Large industrial SLS 3D printers.
Are you guys able to listen to the audio? Anybody? Okay, so 3D printing is actually led
Yes,
by
sir.
like,
It's audible.
okay, cool, thank you.
Use a laser to melt thin layers of metal or plastic powders. Plastics are by far the most common, but metals can also be 3D printed. Depending on the size of the part and type of 3D printer, a 3D print usually takes about 4 to 18 hours to complete. However, 3D printed parts often require some post-processing to achieve the desired level of surface finish.
Okay, basically 3D printing is a layer by layer process. So suppose you are actually cutting a couple of circles in a paper and you stack it one above another, eventually you will get a cylinder, right? So similar to this, any geometrical shape can be sliced into thin slices digitally, and we fabricate each slice at a time. And even though the technology is same, we are actually using different approaches to attain the same output in different 3D printing technologies. So let's see what are the possible 3D printing technologies. The first one is material extrusion, where the material is actually extruded, and the what polymerization is actually, we are instead of extrusion, we are actually selectively polymerizing a liquid plastic into the desired output. And powder bed fusion is actually, we are using a laser beam in order to melt the powder into the desired form factor. So the power SLM is also, the first one is actually sintering and the second one is actually melting. The binder jet is also similar. Instead of a laser, we are actually spraying some sort of adhesive material into the powder, similar to super glue kind of things. So just in order to understand easier, you just this is a super glue kind of thing. So it's actually selectively gluing the material. So material jet is actually similar to the inkjet printers. They are directly spraying the material on top of one another, and we are eventually getting the desired output. So the direct energy deposition is a method where we are actually spraying the molten powder into the material. And this is actually part of a rocket booster, which is actually created by a company called the Relativity Space. And these things are possible only with 3D printer. So these are sheet lamination. We are successively gluing and cutting sheets on one top of another, and eventually we are getting the output we are required. So these are all working on the same philosophy that 3D printer will be sliced the model into thin layers and fabricating one at a time. But the technology they are using will be different. The tools they are using for achieving the same result will be different. So these are the few machines. And these are some design rules we should be considered when designing for 3D printing. These are some examples which you can achieve with 3D printing. This is a completely 3D printed dress. I don't know why the remaining photo was not. Okay. So you can, the complexity of the material we are fabricating is not a concern in this case of 3D printing. On the first image, you can see the robotic leg of the robot Boston Dynamics Arcless. So here you can see the pipes and cables going through the leg. And the second one, they are actually completely replaced it with a 3D printer. What happened to the cables and the hydraulic tube is that they are actually integrated inside the structure itself. So the structure acts as a mechanical member as well as a carrier for the hydraulic fluid also. So here you can see a rocket engine which is actually completely 3D printed. There are vehicle, medical devices, robots, fashion, dental. Here is actually an electric motor which is actually 3D printed. So in 3D printing, you don't have to worry about the design complexity because it's fabricating one layer at a time. And at some point, every part of the object will be accessible to the printing head. So the next one is actually CNC machining. So the CNC machining is actually a subtractive manufacturing process.
CNC machining, or computer numerical control machining, is a digital manufacturing technology. It provides high accuracy parts directly from a CAD file. CNC machines can rotate tools around a number of axes, usually 3 or 5. The basic CNC process can be broken down into 3 steps. An engineer first designs the CAD model of the part. A machinist then turns the CAD file into a CNC program called G-code. With this G-code, the machinist sets up the CNC machine. Finally, the CNC system executes all machining operations, including tool changes, cutting operations to create the part, and cooling of the part and tool. During manufacturing, CNC machining tools such as mills, lathes, grinders, and routers are automated and controlled by a computer. This means that little human supervision is needed during the manufacturing process. CNC machining, or computer numerical control machining, is a digital manufacturing technology.
So these tools are commonly available in universities and colleges. So why I am specifying this, you can access this from your college or university itself. So or a local workshop nearby probably have these machines. So there are different kinds of CNC machines. Usually they are called milling machines and turning machines. So the milling machine, the stock material will be in the standstill and the cutting tool will be moving. On the lathe, the cutting tool will be stationary and the stock material will be moving. So there are machines also which have the capabilities of both combined, which are called turn and mill centers, which can turn as well as mill on the materials. So these are some examples of 3D printing. This is 3-axis router, 3-axis milling machine, and 4-axis milling machines which can cut part which having symmetry around a cylindrical symmetry. So the 5-axis complete 5-axis machines which can be used for creating very complex parts which actually need undercuts and complex geometries which cannot be accessed with the 3-axis or 4-axis machines. So there are also CNC grinding machines where in some areas similar to the parts where we are actually interfacing with some standard interfaces like bearing housing, bearings and some bushes. So we need very tight tolerances in those areas. So in those scenario, after the milling or turning operation, we actually grind it with the CNC grinding machines. Sometimes the geometry will be very complex and tedious to mill with some standard machines. The robotic arms could be used for milling those parts. These are used in the entertainment industry, aerospace, as well as vehicle modeling industries. So whenever you want some large models which needed to be machined, robotic arm is a choice. So these are some machines which can be used for CNC milling. So these are some concerns you should be addressed while designing for CNC milling. The tool access, tool geometry, shapes, and undercuts. So even though you can directly relate these things right now, whenever you are planning to scale your product, these aspects will come across your way. So just understand that, or just get familiar with this term, so that sometimes when you have to use, you will have the knowledge that there is a technology for this and I can use that. So that's the only instinct you should acquire from this session. So maybe you don't have to use these things in for the current hackathon aspective, but whenever you are planning to scale your products, these things will come in place. So these are some examples for a 3D print CNC milled operation. So it can objects of varying complexities. So the next one is CNC cutting machines, which are laser cutters and foam cutters, wire ADMs, digital cutting knives, vinyl cutters, etc. So these are planar operations where you can do any three-dimensional geometries out of this, but whatever we can be cut from a flat sheet of material, these machines are the best choice. So if you can design something uh, which can be assembled with some parts cut from a flat sheet material, instead of going for 3D printing or CNC machining, the CNC cutting operations are much cheaper. So the complexity of design will be inversely connected. So the least difficult one will be 3D printing. Whatever you're designing, it could be 3D printed. The second complexity will be CNC machining. You can design something and it could be somehow fabricated with the CNC machine. And for this CNC cutting operation, you need to consider the interfacing points and the cutting tolerances, all sort of things in order to have a decent uh, output. So these are some machines used for CNC cutting operations. And these are some terminologies which will be useful when you are going somewhere for CNC cutting. So the curve is actually the gap between the material or the cutting diameter of the tool and choosing the material. Certain materials may not be able to cut in certain machines. So usually some sort of plastics are not recommended for cutting in laser cutters. So just aware about what kind of materials you can cut with the machine you are wanting to use. So cutting order, so tabs and bridges. These are higher dimensional variables you don't have to worry about right now. So these are some projects done on these cutting machines. These are cardboard furnitures and leather cutting and water jet cutting, very thick stainless steel and ceramic composites. And this is actually an interesting outcome of a laser cutter where you can laser cut and create flexible surfaces out of hard sheet material. So these are called curve bendings and sheet metal objects. So these things are possible with the CNC cutting machines. So one aspect is that the next one is you want design. So suppose you want to create an extension of an already existing entity, and you want to, in order to create the remaining designing, you have to translate that physical model into the digital domain. So in order to acquire that physical dimension into a digital world, you need some sort of mechanism to measure it and represent it in the digital world. So 3D scanners are best examples for these things. So you can scan a person's hand or a part of a vehicle, and you can design something like a prosthetics for the hand or an accessory for the vehicle. So these things are possible with 3D scanners. There are expensive scanners as well as you can use your smartphone as a scanner. So these days, most of the smartphones come with a LiDAR sensor, or you can use photogrammetry, which is actually taking a couple of photos of the object and they are digitally processed in the cloud and they will give a digital model. So there are multiple options if you are want to create a prosthetic or something which should be measured from the physical world. You can use these 3D scanning devices or your smartphone with the camera or lidar sensors. So this could be used for reverse engineering, quality inspection, medical, art, custom output, games, for creating characters for the game, educational, forensic, etc. These are just some examples. So these are the electronic production equipments which, so suppose you want to create a PCB for tomorrow, you can use just the PCB milling. So you can send it to a fab house and you can wait it for 1 or 2 week in order to get it back. So you can just PCB mill it in your college itself. And there are pick and place machines, inspection microscopes, testing and debugging equipments. These things are available in any standard laboratory inventory, and you can use this for testing, evaluation, and construction of your electronic circuits. So I'm not getting any deep into these things because that's not our priority right now. So these are some logic analyzer, oscilloscope, microscope. So those could be used for testing and evaluating your electronic designing. So these are the outputs which you can get from the PCB fabrication equipments. So for this hackathon, you need not have to design and fabricate these things, but it is okay if you can fabricate something. There will be added points for that. But you can digitally simulate these things also. I can share you a couple of tools which you can use for simulating and creating digital replicas of these things at the end of this presentation. So just understand these things are possible around you. So in order to fabricate something, you need to design differently for different machining processes. So just I mentioned earlier, you can 3D print almost anything. So the 3D printer need not to have any understanding of the complexity of the design. So you just design something and you just consider some basic aspects of the printer, something like tolerances and clearances required. Other than that, you don't have to worry about anything. You can print and directly use it as a product. But in the case of a laser cutter or a CNC machining, you need to have a better understanding of the material you are using and the arrangement of the tabs and clearances. So you need to construct something out of a flat material and you need to decompose the 3D model into some flat materials and you have to fabricate it as flat and there you have to physically reassemble into the final model. Where in 3D printer you don't have to do that. Similarly for CNC machining also. So how do you arrive at a design intent? So basically, in order to design something prior to do the designing process, you ask some basic questions. So that's actually part of the design thinking exercise we will do. So what are the requirements I am really going to address? So the problem I am facing is actually a genuine problem. So and whether this problem could be addressed by within my technical knowledge or anything I could be accessible right this moment. So there is no point in having uh, some solution which cannot be achieved in certain period of time. Whether these things could be accessible and these things could be achievable. So the what are the requirements is very important. What are the operating conditions is very important. Is it going to operate? You cannot design the same object for a clinical application and the daily usage. So you need to design something different for International Space Station and your office inventory. So where it is operating, the operating condition is also very different, a factor for design intents. So what material can be used is also subjective so which is actually depending on the outcome we are actually expecting. For food application, we need to have certain kind of materials which are approved by the FDA or any regional entities for food related plastics. So we are also need to concern about the material we are actually going. Even though it is visually appealing, sometimes we may not have may not be able to use that in that specific product. So the how strong it need to be and what is the cost. The cost is actually very important. There is no point in creating something which nobody can afford other than having an art piece in a museum or something. So usually our product need to be affordable and scalable. So that should be also considered in mind. So even though you cannot fabricate all these things during your presentation, final presentation day, you can specify these are the materials we are going to use and this is the approaches we are going to used for developing this product. So these things could be useful for your final presentation also. How can it be made, which is actually very important question. So there is no point in developing some designs which cannot be fabricated in any point on time. So the things could be fabricated is also same. So here you can see 4 versions of a kettle which is actually fabricated for 4 different perspectives. So one is actually we have fabricated with a metal, one is glass, one is ceramic, and one is some sort of plastic material. So depending on the end use condition, even though all of this will serve the same purpose, the appearance and the intention of the products are different. So let us familiar with some tools which you can use for this workshop and your future endeavors in product development or prototyping journey. So basically there are some tools for ideation and there are tools for designing and there are a lot of tools for engineering and there will be tools for design validation. So I hope few of you are familiar with some tools in these individual domains, but I can have a quick walk through the tools which you can use. So for the ideation, you can use Figma. You already learned about Figma, which is a wonderful tool for brainstorming and the curation of ideas and developing basic prototypes for your actual product. The Notion is also a wonderful tool. The Mural is also similar to Figma and Canva, Draw.io, Mind. So these are all tools which you can use for ideation purpose. You can use this to share your ideas and create a collective understanding on the problem. So these tools are very useful for interactively curating ideas and refining your design intents. So these could be used for your design thinking processes. So draw.io you can. So one thing we can expect is that if you can develop the product, so you can at least develop the flow chart or a block diagram of the project you are actually going to do. So the hardware products are very difficult to fabricate in 1 or 2 days. So one way to impress or satisfy is that you have to prove visually that these things are possible with the technology time which we can have sometimes later. So by defining your intention very specifically and you can communicate those ideas visually, we can easily prove that these things are possible. So the visual representation of a problem is very important. So you can use draw.io for your schematic or drawing representation, flowchart, block diagrams, etc. And the mural is also similar to Figma. You can collectively develop some understanding and you can brainstorm and develop a board where you can share all your ideas and you can easily present your ideas from these online platforms. So you can have add photos, videos, and your little bits of knowledge, wiki, everything could be added in a very large canvas and which can easily navigated and it could be easily shown to someone else. So next is some design tools which I specifically mentioned some tools which are openly accessible to anyone, and also there are some industry standards tools. So which one, these ones having a larger thumbnail are easily accessible to anyone, and the smaller icons are industry standard. If you have access, depending on your accessibility, you can choose any of the tools. So Photopia, Game, Krita. So these could be used for creating a visually appealing presentation of your model. So one example is Blender. You can actually create concept models, animate them, and render them. So these things will make others to understand your problems in a better manner by creating a rendered model or a animation of your machine. You can translate your ideas much easily to a wider audience. So rather than explaining it verbally and having a hard time to make them understand these things, you can directly model it in some other software and you can present the same to the audience. So it's actually an open source tool. So I have given a couple of links where you can have the documentation and videos. So you can just Google literally and there will be a ton of material to learn. So just hinting some solutions, possible solutions we can present for your final presentation. So the next one is some engineering and CAD tools. So Tinkercad, SolidWorks, OpenSCAD, Solidedge Community Edition, FreeCAD, Autodesk Fusion, Onshape. So these all are some freely available tools which you can use for developing your concept designs and your mechanism. Or if you want to create a physical model, you can use this design to a 3D printer and directly fabricate the model, and which you can use for your final presentation also. So Tinkercad is actually a very intuitive and easy to use program which can be used in the web itself. So you can, this is actually working on some primitives. So if you don't have much understanding on CAD modeling and you are new to this, Tinkercad is a possible option, but it is not very easy to do complex machine designs. So if you are planning to make something very simple like a copy maker and a robotic arm, so you don't need to have any greater understanding on the CAD perspective, constraints, and parametric modeling. So these are basic understandings are only required. With a couple of 1 or 2 3D designing videos, you can easily get grab on the design processes. So if you are new to modeling and you want a quick solution, you can go for Tinkercad. The next work is SolidWorks App Kits. So I don't usually recommend this because it's actually uh, designed for small KG students. But you can have beautiful simulations of mechanism in this. Also, if you want to simulate a mechanical joint or something, and you need to show some perspective of the machine in action, this could be implemented with this. So that's the only reason I included it in here. So Onshape is actually a very mature CAD software which you can freely access in the cloud. So you can use it from the browser, and it has capabilities of CAD modeling, animation, rendering, mechanical simulation, and all sort of. It's a very mature CAD modeling software which you can use for um, developing your CAD output and showcasing your desired product output. So uh, this is not much hard to launch this product in a couple of hours. You can try 1 or 2 hours and you can easily start designing your complex design from it. So one other possible solution is Autodesk Fusion 360, which you have to install on your computer, and this is also a very intuitive and easy to use mature CAD software. Even though it's not as easy as Tinkercad or any other software, but it's a very capable and very fast learning curve. You can easily learn it. So if you want to design something and present something, you can definitely try the Fusion framework. We can create some small design models to complex machines in this, and you can render and simulate and give showcase your outputs in it. So the next are some ECAD softwares. There are millions of possible solutions for this. So I can share you a couple of one which I felt useful for you guys. So fixing design spark, deep trace, circuit maker, fusion, electronics, equal, KitKat, ECDA. So these all are freely available tools which you can use to create your design and showcase your product. So fixing is a very primitive, very easy to use, not primitive, I would say. So it's very easy to use, simple PCB fabrication tool where you can have the schematic arrangements where you can be used it for your documentation purpose as well for creating your own custom extensions for your uh, microcontroller boards. So this is a very easy to use, simple PCB designing tool fixing. So the next one is Autodesk Fusion or Eagle, which are both are same. One is on cloud and one is an installable version, which is a very capable ECAD software where it can create complex electronic circuits. And you can directly integrate those things inside your mechanical design also. So these are very closely integrated systems, Fusion and Eagle. So you can use your directly export these CAD models of this electronic circuit into the mechanical environment, and then you can use it. So the next one is ECDA, which is a cloud-based software. So this is also very easy to use, learning curve. Provided you need to dedicate some time to understand this. So if you are planning for fabrication or creating a proof of concept around a PCB, you can definitely go with these tools. Or else if you are planning to scale your product into something more of a commercial or a fabricatable design, you can consider these tools. So the next one is the minimum thing you can do with electronics is these tools. These are some amazing simulation tools which you can use to prove your design. So you don't need to have any physical infrastructure in order to try this, but you can prove your design and you can implement your basic models in this software. So you can at least try these tools during the hackathon, and if you have more time and capability, you should definitely go for the fabrication also. So this is actually circuit IO. Suppose you don't know how to connect a couple of devices together and create a starting code. This is the right place you should go. So you can drag and drop a couple of microcontroller boards and IO devices. This website will automatically create a schematic and a starting code and some construction guidelines in order to create the project. So you can start your design process from this basic understanding and you can create detailed models from it. So this is actually the Tinkercad circuits. This is actually part of the Tinkercad ecosystem by Autodesk. So where you can create and simulate electronics inside a web browser. You can program it. You can program it with Arduino style of coding or with this block kind of approaches. So you can create a couple of models and you can create a simulation of your expected outcome in Tinkercad. So this one is also on another web-based electronic simulator, which is actually much more capable. So this can actually simulate the ESP32 series of microcontrollers and the new Raspberry Pi chips, Arduinos. This can support MicroPython and C++. So if you are trying to implement something more of an IoT kind of devices, so you can use this environment where you can simulate even the Wi-Fi perspective of the ESP device in this environment also. So you can try your IoT development also in this environment. So you don't need to have any physical devices. So you are not limited by the fact that you don't have a physical devices. So this is a wonderful platform. So the next one is actually a couple of management tools. So you need to track what you are doing. So because that's the only thing you can showcase us. You have, in order to prove that you have done something which is useful for the final perspective. So prior to creating a video, these kind of a documentation tools will help you to curate quick understanding on the problem, or else you can directly embed this content into the final presentation video. So Git is a wonderful tool. Fusion 360 Cloud, you can share, manage all your assets. Asana, Trello, Slack, Notion, GitLab, anything, Figma, anything is very fine. So this actually, I have given an example of a Notion where you can create a page and curate your contents. So you can directly embed your wikis and your little thoughts in this. And you can also use this to track your projects, similar to a Kanban board or something. You can plan your projects, and whenever we are asking something, you will be having a dashboard to showcase us. So as during the mentorship sessions also, these things will be helpful because you have something to showcase us. So, and if we can lively track what you are working on, where you are actually stuck in. So these insights could be easily grabbed from these kind of management tools. So these are a couple of examples we done in rapid prototyping. So these are done in my lab in Cochin. So I'm actually working in Fab Lab Cochin, where we are actually working on rapid prototyping of projects for startups and design projects for companies and government entities. So these are some of the projects we actually worked on, and the students came here actually made this also. So some of these are made during the pandemic also. So So if you guys are interested in learning more about building prototypes and how to choose materials or how to implement your design into a more physically possible, appealing entities, these are some links which I felt useful for myself when I learned all these things. So I thought these would be helpful for you also. So if you have time sometimes, even though not now, you can choose these links to learn something new. Okay, hope I have done with my presentation. So you can ask any questions or queries. Hello? Anybody have any doubts or something maybe? Am I audible?
Yes. Yeah.
Okay. Anybody have any doubt or something? Or you can reach me during the mentoring session also. So if you don't have any doubt, but you happen to have some times doubts later, you can reach me during the mentoring session, or I will be available around. You can reach me in my WhatsApp, or I can have a video call or something. If you have something need to be figured out, I can help you on that. Okay, all the best. Kudos, guys. Shaheen, what's up next?
Hi guys. So how was the section? Yeah, so the recorded video will be shared to you soon, okay? Like for that particular comment, okay. Yeah, so hope all are good. So like we are gonna start our hackathon now, and so try building your product or prototype or whatever it may be, and also make some ideation and all, like build something that is useful. Okay, so tomorrow morning we will have one review meet like about 9 and all, like we will update more about that in the WhatsApp group. If you have any queries, you can ask in the WhatsApp group. Also, if you want some mentor support and all, like in any stack, there is a link provided in the WhatsApp group for mentor support. You can just fill that and book a slot for you. Corresponding mentors will contact you for that. Okay. So, and also if you have any queries, do ask in WhatsApp group, or if you want to ask now, you can also ask now. Okay, that's also okay. So if everything is good, we can have a wrap. So can you please respond at least in chat, like, is everything okay?
Yeah, it's okay for me.
Okay, great. So hope everything is clear. So yeah, that's it. So I think we can wrap this meet. So if you want any support, you can ask in WhatsApp group, or you can reach us, or like you can fill the mentor form. Like anyway, you can ask your queries and all. Okay. Okay. Okay, that's it. So thanks for joining the meet and wish you all the best. Okay, bye.